Today, I'm rapid firing through 3 more ideas for my final basement lab project. Hey, I'm Leon, and I'm once again experimenting with microalgae. If you watch any of my recent videos, you'll know that I'm currently developing my idea from the final project I'm going to run in my basement lab. And I want to take care with picking this idea to make sure that it's the biggest and best project I run. So for the past few weeks, I've been running quick idea sprints, trying to figure out which ideas I should keep and which ideas I should kill. But this past week, I realized that I have not been sprinting fast enough. So this week, I'm going to rapid fire through 3 quick ideas I have for this final project and try to get to a final idea in the next couple weeks. Idea number 1, a personal carbon sink. I'm sure you know that we all exhale carbon dioxide. But what I'm guessing you don't know is how much carbon dioxide you exhale in a day. Take a guess. Got a number in your head? Great. It turns out it's about 0.66 kilograms of carbon dioxide every single day. Now, an idea I had that I thought would be pretty interesting is if I were to take some algae and just put them on my desk, and as I breathe out my 0.66 kilograms, my algae recycle all that carbon dioxide and output it as oxygen for me to breathe. Essentially, my room turns into a circular economy of oxygen and carbon dioxide. Now, it's a pretty awesome idea in theory, but putting it into practice might be kind of hard, as I've realized. Because while algae are probably the best carbon capturing organisms on our Earth right now, they're still really slow at it. And that's because the process of photosynthesis, which algae use to capture carbon dioxide, is itself just really slow. It's slow in algae, it's slow in trees, it's slow in all other plants. So even though algae are great at capturing carbon dioxide, it would still require a lot of algae to capture all the carbon dioxide I emit in a day. I'm probably looking at 100 liters of algae in total, running continuously. And the 100-liter piece is hard, but what's even harder is getting that continuous culture set up. Continuous culture is a different form of culturing that I've never really tested before. I've only ever done batch culture. In batch culture, essentially what you do is you take your algae, you grow them up, they reach their highest point of growth, and then they die. You harvest whatever you're going to get out of that, clean out the culture, empty your jar, and that's your whole culture. With continuous culture, what you want to do is always have algae in that jar, which means that you need to do 2 things. You need to constantly be removing the dead algae, and you need to be removing and replacing the medium, the nutrient medium the algae need to grow, which has all the important nutrients like nitrates and phosphates. So setting up a continuous culture is actually a lot more difficult than it sounds. You need to have like tubes running out of the jar so that you can remove the medium accordingly. You need to every so often transfer all the dead algae out and replace it with more new medium, really. So setting up a continuous culture that can actually absorb all the carbon dioxide I exhale may or may not be possible. But it's an idea I still want to leave on the table as a concept, because I think setting up a continuous culture of algae, even if it's not absorbing that much carbon dioxide, would still be really cool. Now, the next idea I had was to make fertilizer out of algae to help me grow a garden. A few years ago, I started a tomato garden in my backyard, and I was contemplating doing that again this summer. So it would be really cool if I could also incorporate all my algae experiments into that garden. So I'm thinking if I could take my algae and make it into fertilizer, that would be a really interesting use of it. Now, making algae fertilizer is a pretty well-known thing to do, because algae are great at storing nitrates and phosphates and potassium inside their cells, which is something that a lot of plants need. So if you were to take algae, grow them in some water, have them absorb out the nitrates and phosphates and the potassium, and then gather all that algae and then turn it into a sort of slurry and then apply it as fertilizer on some land, that could be a pretty effective way of fertilizing your plants. And it's a lot more sustainable than the chemical methods of producing fertilizers that we have right now. Now, this runs a bit into a similar problem as the personal carbon sink, in that algae are kind of slow at growing, and they're even slower at becoming dry algae biomass. What you want to do in this situation is take your liter of algae culture and grow it for a while, and then when it's done growing, take out all the water and get just dry algae at the end that you can then process into fertilizer. But doing that has a really low output. Just to give you a sense, when I was working in a local lab, I was putting in 1 liter of algae culture and getting out about 0.3 grams of actual dry algae biomass. So to get enough fertilizer to cover even a few plants, you'd have to run something like 50 liters of actual algae culture. Now, this isn't impossible, but it's not the most impressive or ambitious project I've done. Making algae fertilizer is a cool concept, but it's not that ambitious to just grow algae, or rather wait for them to grow, and then just dry them up and then turn them into fertilizer. So I have a feeling I'm not going to be rolling forward with this idea. Now, this last idea I have is pretty outlandish, but I just started thinking about it when I learned about the algae biofilms from the last video about algae-based biophotovoltaics. In that video, I talked about how scientists have been able to take algae, basically an algae culture, and mix it with a substance called sodium alginate, which is not related to algae. The algae comes from something completely different, but essentially what it does is it turns the water with the algae inside into a sort of gel-like biofilm. You can see it on screen. And I was thinking, what if you could take that and make it into some sort of algae capturing film that maybe you could, I don't know, attach to a window or even make into a window. Essentially like stained glass, but with algae. Now, the best part of all of this is that the biggest thing that algae need to grow is sunlight for photosynthesis. So if you were able to stick your algae biofilm to a window, they would be in a perfect place to gather all that sunlight, gather the carbon dioxide from the air, and metabolize all of it to grow successfully, which I think would be a pretty cool application of algae. But all things considered, this isn't really much of an experiment, it's more of a can I accomplish this? And I think it'll be pretty cool to do this as a bit of a side project, so I might look into this sometime in the future, just while I'm running my big project, test out this whole algae window idea on the side. So there we go. I've kept one idea, killed one idea, and I have an idea to work on the side as I work on my final project. I'd call that a pretty successful idea sprint. Now, as I'm looking at the list of ideas I've kept, algae light bulbs, continuously culturing algae for the carbon sink, even the fertilizer idea, which I did ultimately kill, I'm seeing this theme of using algae to replace stuff around my house. And that's giving me inklings of another potential idea that I'm gonna look into over the next week and do an idea sprint video about next week. So if you want to see another one of these videos where I rapid fire through an idea and see if it's possible, make sure to follow on LinkedIn, subscribe on YouTube, and as always, I'll see you in the next one.